Okay, so in Unit 1 here, we're going to start with vectors and scalars. I've said this many times, but vectors and scalars is a topic that will come up in every single unit that we do. Just like converting, just like units, everything is either a vector or a scalar, and so learning it now will help you throughout the entire year. We're going to start off with what they are. Scalar quantity is just something that is described by its magnitude only. We're just talking about a number here, whether it's a mass, a volume, speed, time. You can see the examples I give down there. If someone in the Olympics was lifting 95 kilograms, that's a scalar quantity. It's just how much, or how fast, or how far. That's it. And the way they indicate that in the book is they'll either just have a bold letter, so like A or X there would be bolded, or they could have them in brackets like you're seeing. Either way, that's how you'd see scalar quantities show up in the textbook. An example, though, is if you were caught speeding. Let's say that you're flying down the road and a cop sees you. And the cop calls up his buddy and says, "Yeah, I just saw him going 90. And hang up the phone. There's something lacking there. Great. 90 what? 90 miles an hour, 90 feet per second. Like, what are we talking here? That's a unit, but you're just giving me a number. You're giving me a quantity. I need more than that to go chase this speeder. And if they said, oh, well, they're going 90 miles an hour east on Route 130, well, that's what we call a vector quantity. So vector quantities have magnitude and direction. So there's a number, but there's also direction placed with it. So velocities or displacements, forces, a lot of things are vectors, and with the vectors you have to worry about which way. So they can be in the positive direction, the negative direction, north, south, east, west, northeast, southeast. Pick a direction, and really all a vector is a line drawn from tail to tip. If you want a large vector, we need a long arrow. If you want a short vector, we need a short arrow. And to know which direction, just put an arrowhead on the vector. With vectors, we can multiply, we can divide, we can do a lot of different things with them. The examples I'm showing you there, if vector A was a certain quantity, and I then wrote 3A, 3A would be 3 times that quantity. If I had vector A, but I had negative A, that vector has the same magnitude, but the negative just means it's in the opposite direction, a complete 180. That's the big difference between vectors and scalars. We've got 2 examples here. You can see that vector A is about 3 centimeters long on this ruler, and vector B is 6 centimeters long on this ruler. By using the scale there, I know that both vectors are pointing in the northeast direction, the up and to the right direction, but vector A would actually equal 6 meters per second, and vector B would equal 12 meters per second. We have many different vectors we'll deal with. They're showing you a displacement vector here as the quickest way from point A to point B, but you could have vectors like the ones we just saw, A and B, that are parallel, go in the same direction, anti-parallel, go in opposite directions. What you can do with vectors is you can add them, you could subtract them, you can do lots of things. You can do all the basic math that you do with normal numbers, but with these arrows. So in this example, if you're trying to get from point 1 to point 3, you can take vector A, which takes you from point 1 to point 2. You can go from point 2 to point 3 with vector B, or you could just take the quickest path from point 1 to point 3 following vector C. So really, what we're seeing here, vector A added to vector B is equal to vector C. And writing the letter with that little arrowhead on top is a way to properly write vectors in your equations. You can see here, vector C is the addition of vector A plus vector B, but like we saw in the treasure hunt, you don't have to follow A plus B. You can go any way you want to try and get to the same final destination. I could do A, then B, but as the next slide shows, we could do B, then A. B, then A is the same thing as adding A plus B. They get you from start to finish. Okay, and even in this example, we've got three vectors. Vector A plus vector B plus vector C gets you all the way over to that far point. But you could just do vector A and then B plus C, or A plus B plus C. Combining vectors through addition really has no effect on the result. And that's what we call that. When we combine multiple vectors together, we call them a resultant. We can add them graphically, we can add them algebraically. We'll save the algebraic with components for the next lesson. Okay, so in this example here, what I'm going to do is I'm going to draw some vectors, and we're going to combine them and see what the resultant is. We have three vectors here, vector A plus vector B plus vector C. What we can do is we can move the vectors around to find a resultant. So that means that I can redraw these vectors and put them wherever I want. I do not have to keep them in the locations that they're at. Just like you did in the treasure hunt, you want to add vectors tail to tip to find your resultant here. So if I wanted to do an example of, let's say, A plus B. A plus B would give me, I'm going to start with vector A here, so I'm going to leave vector A alone, and all I'm going to do is move vector B on top of it. So there's vector B, and vector A plus vector B will give me the resultant that we see right here in orange. That is vector R, our resultant vector. And I could have done the reverse. If I did B first, then A, that puts me in the same exact spot. The order of addition does not matter when combining vectors. Let's do another example. We'll do C minus B. Okay, when we're combining C minus B, that means I want to draw vector C first, and then minus B is, remember, the same magnitude, same length as B, just opposite direction. So here is minus B. That's minus B. So the resultant of those two vectors goes down here in the third quadrant. Addition, subtraction is just doing vectors tail to tip to find a graphical solution. You can do it with 3 vectors. You could do it with 4 vectors. You could do it with 100 vectors. And that's the way to quickly and graphically combine vectors.